Hello everyone, my name is Anand Sharma. I am graduated from the Central University of Sagar and I am also done post-graduation from there only. I have 4 years of teaching experience in the field of physics and today we will understand an interesting topic in physics, that is time period of pendulum in every case. First we will derive the method how to calculate the time period of a pendulum. Okay. So let us consider our pendulum. This is the rigid support, for example. This is a rigid support. And this is, for example, this is the mean position of our pendulum. Now consider our pendulum has taken theta angular displacement in this positive extreme. For example, this is a negative extreme. What is the motion of pendulum? The motion of pendulum is SHM, simple harmonic motion, for very short angular displacement. Short angular displacement. Angular displacement. Okay. Now for example, this is our pendulum. This is our pendulum. Okay, it is taken a theta angular displacement in this positive extreme. For example, the length of the pendulum is L and this is x is the perpendicular distance from the mean position. Okay, now if a pendulum was started from this position, let us consider that this is the height h, and if this is a whole L, if this is the whole L, then this will be our L minus h. Okay, now this is, let us consider this will be our L minus h. Now we will understand how to calculate the time period of the pendulum. So if the pendulum is having mass m, if the pendulum is having mass m, so this mg will be in downward direction and this mg cos theta will be in parallel direction with the string of the pendulum, and this mg sin theta will be in the direction of this x is equal to 0. Now we will consider that, sir, in case of pendulum, sir, what will be the restoring force which is making this pendulum back to the x is equal to 0, that is mean position? What is the force which is acting on the pendulum to making it direction back to the mean position? That is only this force mg sin theta. If this is the force F is equal to minus kx, in case of pendulum this force will be equal to mg sin theta, or we will say that minus mg sin theta, because it is working as a restoring force. It is working as a restoring force. Now what is the value of this sin theta here? Sin theta is equal to perpendicular upon hypotenuse, है ना? So what is sin theta here? Sir, sin theta here will be, sir, perpendicular. What is perpendicular? X, and what is hypotenuse? It is L. So here we will put the value minus kx is equal to minus mg sin theta is equal to x upon L. Now it will become minus kx is equal to minus mg upon L, or x here. So we can say that, sir, value of k is equal to mg upon L. We have already studied what is the formula of time period. Time period is equal to 2 pi under root k upon m. 2 pi under root time period is 2 pi under root m upon k. Now we will put this value of k in this formula. It will become 2 pi under root L upon g. So this is the formula of the time period of pendulum in case of this type of pendulum. Okay, now we will consider our case 1, when we will have some case in how in many situations how we will calculate the time period of pendulum. Okay, now for example, case 1, for example, our pendulum is moving in any car or any lorry. For example, this is our lorry and this is like this. There is one pendulum which is in this lorry only, है ना, which is going in this direction with acceleration a. Now what will be the time period of this pendulum when it is going in this direction, है ना? So sir, in this direction, in this case, first of all we will calculate the A effective. Our A effective will be, sir, our A effective will be under root G square plus A square, or we will say that under root G square plus A square whole power 1 by 2. So our time period will be T is equal to 2 pi under root L upon, in place of G we will put this G square plus A square or 1 by 2. In we can say that the G effective also, sir, G effective also. So our time period of pendulum will be like this in this case. Now case 2, now for example consider case 2. Now consider the body is in a lift. For example, a lift, this is a pendulum which is in a lift. Now for example, the first time the lift is going up in upper direction, and in second case the lift is going in downward direction. When the lift is going up, our G effective will be, sir, G plus A. When the lift is going in downward direction, our G effective will be, sir, G minus A. Now in this case, sir, time period will be, T is equal to 2 pi under root L upon G plus A. Now in this case, T is equal to 2 pi under root L G minus A. Is it clear? For the free fall के केस में क्या होगा सर? What free fall के केस में होगा सर? Free fall के केस में होगा सर T is equal to, because G minus G है ना, so 2 pi under root L upon 0, and it will be infinity. In case of free fall it will be infinity. Now case third we will consider. Case third, when the pendulum is in the body which is exhibiting uniform circular motion, uniform circular motion. Now in case of uniform circular motion, sir, our G effective will be under root, it will be under root G square plus V square upon R. V square upon R is a centripetal acceleration, and 1 by 2. Okay. Now, so what will be the time period? T is equal to 2 pi under root L by this G square plus V square upon R 1 by 2. One more case is there when the pendulum is in a inclined plane. For example, case 3. When the pendulum is in a inclined plane, for example, the pendulum is in any inclined plane. For example, this is like this. Okay? Now here this will be the mg, and this will be a mg cos theta. For this mg cos theta, our G effective will be only G cos theta only, है ना? Now our time period will be, sir, T is equal to 2 pi under root L upon G cos theta. So this was the video of how the time period of pendulum is there in many cases and how we calculate the time period of pendulum. Thank you.